Hello, and thank you for joining me today. We're going to talk about simplifying algebraic expressions. And we're going to see several different tricks today. But the first thing I want to talk about is just this idea, algebraic expression. What does that mean? Well, you'll notice that all of the expressions that we look at today have some letters in them. We call those letters variables. And the variable can be any letter. Oftentimes we use X, it could be Y, it could be Z or M or N. But the idea is that the variable stands for an unknown value or number. So if I'm dealing with a problem where there's a number that I don't know, I just say, let's just call the number X and treat it as if it was a number, but I don't know how to do the multiplication with X. I don't know how to do division or addition or subtraction, but I do know some things about the unknown number, and I'm going to show you some of those things that we do know so that allow us to do our problem. So the first thing we know about unknown numbers is that the same number acts the same all the time. So if I have three different y's, that y is going to act the same all the way through. So I can do things like combine like terms. Combine like terms. And that's the first skill we're going to practice. Now, let me give you an example. If I said 3 times 2 plus 5, the order of operations says I would do the 2 plus 5 first, which is 7, and then I multiply it by 3, which is 21. But there is this thing called the distributive property that says I can take that 3 and multiply it times each piece. 3 times 2 is 6, plus 3 times 5 is 15, and when I add 6 plus 15, I get 21. So it works both ways. Well, what if the 3 wasn't a 3? What if it was an unknown number? What if it was x? X times 2 plus 5. Well, order of operations, I would still do 2 plus 5, which is 7, and then multiply that times x, and we know that the way we write multiplication with a variable is just the number first and then the variable, and we mean times, so 7x. But the order of operations says that we could have done x times the 2 and x times the 5 first separately, which would give me 2x plus 5x, and then normally I would be stuck. I'd just say, well, 2x plus 5x, what is that? But thanks to the distributive property, we already know that it equals 7x, and that's the idea of combining like terms. If the variable parts or the unknown parts are the same, we can add the known parts together. If we're adding two things together and part of them are unknown and part are not are numbers, then we can add the number parts together as long as the unknown parts are the same, right? So they're both x's, so we can add the numbers together. 5 plus 2 is 7, and just say it's all x's. I like to think of it as apples. 2 apples plus 5 apples is 7 apples. If I said 2 apples plus 5 oranges, you would say, well, it doesn't make any sense to say 7 because you don't have 7 apple oranges. There's no way to add them together. You have to keep it separate unless you want to say 7 fruit, but that doesn't really communicate as much information as 2 apples and 5 oranges. Okay, so there's no way to add them together unless they are like terms. And if they're like terms, you may add them together. And that's what we're going to do here. We have 8y plus, how many y's is that? I hope you said 1y, because there's 1y there, minus 2y, and we can add all those numbers together. 8 plus 1 minus 2, that's 7. 8 plus 1 is 9, minus 2 is 7. So 7y plus 3. Now, can we add the 3? Can we just say 10? 7y plus 3 equals 10 something, maybe 10y, maybe 10 without the y. No, we can't do that because we can only add the numbers together if they're talking about the same thing. All of these numbers, 8, 1, and negative 2, we're talking about y's, oranges, let's say. And so they were telling us something about how many oranges we had. But this 3, we don't know what it's talking about. It's talking about something different, though. Certainly not oranges, certainly not y's. So we can't add it to the other numbers because it's not talking about the same kind of thing. Okay, there's our answer, 7y plus 3, and I want to make one last observation here. Notice that our answer is not one thing, 7y. It's not 10. It's not just a single thing. It's still a sentence. It's still an expression. It's going to have part of it that has a variable and part that doesn't have a variable, and that's okay. It's okay if your answer is not just one thing. It can have more than one thing being added together because we're just doing the operations that we're allowed to do, but some of the operations we may have to leave for later when we know what y equals. Okay, now that's combining like terms. We'll see more of that as we move along. Let's do a little bit of multiplication. I want to show you, this is a really important distinction. I want to show you two different problems involving multiplication. In the first one, we have negative 3. That's being multiplied by this stuff inside the parenthesis, but the stuff inside the parenthesis is a multiplication. It's 21m, which means 21 times m. So actually, I could break this apart and say, well, there's just 3 things being multiplied, negative 3, 21, and m. And do you know how to multiply any of those things? You sure do. You know how to do negative 3 times 21. Negative 3 times 21 is negative 63. I don't know how to do the times m, but that's okay. Nobody does. So until we know what m is, we'll just write it next to the negative 63, and everyone will know that we mean we're going to multiply that negative 63 times m eventually, but we don't know what m is yet, and so we'll have to wait. Okay, now that was one example. Now let me show you a second example. Here it is. It's number 3, negative 8, and that's being multiplied, right? Same thing. We have that parenthesis, negative 8 times next to the parenthesis is multiplied. It's being multiplied, but it's being multiplied by 3y plus 5. It's being multiplied by an addition, and the order of operations says before we can do that multiplication, we have to do the addition, 3y plus 5. But the whole idea with expressions is we don't know what 3y plus 5 is because we don't know what y is. So we can't do that addition. We're not allowed to add those together because they're not like terms. They're not talking about the same thing. So we're stuck. Unless we remember the distributive property says, well, I can take that negative 8, and instead of waiting until I get the 3y and the 5 together to multiply it, I can multiply it by each piece individually. And that's what we're going to do. So we're going to have negative 8 times 3y plus negative 8 times 5. So the negative 8 is being multiplied by each set of things, and then notice now we've got a big multiplication going on, 2 multiplications actually. Negative 8 times 3 times y, which is, we can do the negative 8 times 3, that's negative 24, but I can't do the times y, so I'll just write it, times y, plus, I can do negative 8 times 5, that's negative 40, and normally I would write that as negative 24y minus 40. It's probably a better way to write it. And again, notice the first term had a y in it, and the second term did not have a y in it, and so when I multiplied, I got two different kinds of terms. One has a y, one has a variable, one's talking about oranges, and the other one does not have a y, it's talking about something other than oranges, and so we can't add those together or subtract them. We can't combine those two terms, so we just have to leave the answer as two things being added together. Okay, hopefully you're getting a little bit comfortable with this. Let's move to some more problems. And these are going to just be the same thing. Oops, forgot to erase this one. These are just going to be the same thing over and over again, only more and more complex each time. Okay, so for example, here I have the exact same situation I had before with a distributive property situation, and then a second distributive property situation. Let's talk our way through this. So first of all, notice that the order of operations says add or subtract what's inside the parentheses, 5x minus 2 and 3x plus 1. But unfortunately, in both cases, we have a situation where we're supposed to combine like terms, and there are no like terms, so we can't combine. So we would say we're stuck, we're done, there's nothing we can do, unless we remember the distributive property, which says you can take the thing that's being multiplied outside the parenthesis and distribute it to each term inside the parentheses separate before you do the addition and subtraction. And that's what we're going to do. So we have 3 times 5 times x minus 3 times 2. Okay, so I did the distributive property, and now I can do that. I can do 3 times 5 is 15, and then x minus 3 times 2 is 6. Okay, now same situation here. We had a 2 outside the parentheses being multiplied by everything inside that parenthesis. So they're separate parentheses, so they don't get treated the same. 2 times 3x is 2 times 3 times x plus 2 times 1 is 6x plus 2. Now, 15x minus 6 plus 6x plus 2. Probably the biggest mistake everybody would make here is thinking that negative 6 plus 6x is 0. That's really tempting to do. But notice that they're not like terms. So what I'm going to do is I'm just going to rearrange some things here. I'm going to take that negative 6 and that 6x, I'm going to swap them. I'm going to write 15x plus 6x minus 6 plus 2. And when I do that, I can see now I've got all my x's right there and all my not x's right there, and I can combine like terms. 15x plus 6x is 21x. Because they're both x terms, I can add the numbers. Negative 6x plus 2, well, remember, negative plus positive you subtract, keep the sign of the stronger number. And so it's negative 6x plus 2 is negative 4. And there we have it. Now, are you tempted to say, and then you get negative 17, 21 minus 4 is 17? It's really tempting to say that. But recognize these are still not like terms, so I can't add them together. Okay. This is called the Dorito chip method, by the way. Notice that on each line, I rewrote what the line before equaled, and then each time I did this, it got simpler and simpler until down at the point of the Dorito chip here, I ended up with my answer. And I didn't make it all the way to the point there because there was 2 terms instead of 1. That's okay. We simplified it as much as we could. Okay, let's do another one of these. This is kind of similar. Notice that we have that same situation where we have the parenthesis with something being multiplied outside. We're going to do the distributive property here. So we're going to take 5 times 2a and 5 times 3, because 2a plus 3 cannot be done, but I can do the multiplication. 5 times 2a is 10a, plus 5 times 3 is 15, and minus 10a. Now, it helps me to rearrange these so that all the a terms are together. So I'm going to have 10a minus 10a plus 15. Notice that the sign of each number went with the numbers. So the 15 was positive. It's the plus 15, so I kept the plus. The 10a was negative, so I kept it when I swapped the order. Okay, now we'll combine like terms. 10a minus 10a, 10 minus 10 is 0, 0a plus 15. Of course, if there's 0 a's, we don't even write it, right? If there was 1 a, we would just write a, but if there's 0 a's, we would write nothing. And so the answer is 15. Oh, we like this one. It comes down to one thing. But remember, it didn't have to come down to one thing. It just happened to, because the a's got canceled. Okay. Let's do one last problem. This is a perimeter question. What's the perimeter? And the idea is we have this hexagon that nobody wanted to draw because it's way too hard. But it's a regular hexagon, so all the sides are the same length. And you can tell I'm really artistic here because I clearly drew all the sides the same. And all the sides are 9y plus 1. So we could just write that over and over again if we wanted to. This is going to get really tedious after a while. But you can see that all the sides added together, or all the sides are the same. So we could just come in here and write this as one long sentence and just put plus signs in between each of these. And we probably should write it all out. But notice that they're all the same, and there's 6 of them. That's what hexagon means, 6 sides. So I'm just going to write 6 times 9y plus 1. Oops, my y turned into a v. That's not good. All right, so 6 times 9y plus 1. The perimeter is equal to one side times the number of sides because they're all the same. And this is a distributive property situation. 6 times 9y plus 1 is 6 times 9. Y, and 6 times 9y is 54y. And then plus 6 times 1, which is 6. And I'll put that in parentheses and write kilometers. Again, do we know what the perimeter is? No, we don't. We don't know what the perimeter is because I don't know what y is. So like it's impossible to find the perimeter, but we can find an expression for the perimeter by saying, well, yeah, whatever y is, it's 54 times y plus 6. Thank you so much for watching with me today. Have a great week.